welcome to SDN Tech Forum. So now we are at the very end of our AWS crash course. This is the final demo we are going to build. So far, we learned about various aspects of infrastructure as a service, say compute, storage, security group, VPCs, etc. Right now, we are finally going to build an application, a demo application, which is fault tolerant and at the same time very scalable. So now we'll put all the concept together and create an application. Primarily, we are going to focus on load balancers and auto scaling group. Yeah, so, supplemented by CloudWatch alarms. So if you haven't watched the previous videos, I highly encourage you to go and watch them. So now this is our demo setup will look like. So we have a VPC. Within VPC, we have two public subnets, subnet 1 and subnet 2 in two different AZs, where we have an EC2 instance, which is running some kind of applications. And these application is served or front faced by ELB, Elastic Load Balancer. So that's give you high availability. Now the fault tolerance and scaling will come into picture by auto scaling groups. So we will create an auto scaling group in conjunction with the launch template and stitch it with ELB so that this application is fault tolerant and highly available at the same time, dynamically scalable. All right, so now without losing any time, let's go to our AWS console. Here in the AWS console, you can see we have one instance running, and I already have an auto scaling group and a load balancer. So I'm not going to just walk you through them. We will create this in live here. But why I'm running this? Because I want to show you that some of these things, they are not like, for instance, you can go ahead and shut down an instance or delete terminate an instance or save a state. But for some of the context like auto scaling group and load balancers, they are not available to disable. All you can do is delete them. So as you can see, either I can go ahead and edit or I can go ahead and delete. So what I'm going to do, I'm going to delete everything, all the context, and then we will build the application as depicted in the diagram. So let's go ahead and delete this auto scaling group. Console want you to confirm. So deleting it, and as you can see, this status is deleting. At this point of time, we can move to other context, and let me move to auto scale load balancers. As you can see, we have a load balancer created here. So I'm going to show you that there is no possibility to disable it. All you can do is delete or edit. So let me go ahead and delete so that we can do a clean start. All right. At this point of time, no load balancer, no ASG group. Now let's go back to EC2 dashboard. And what we are going to do, we are going to terminate this EC2 instance as well, so that we don't have anything to begin with. You can refresh. As you can see, there is no instance running. However, some of the instances are stopped, or other instances are shutting down or terminating. So we have a clean slate here. Let me walk you through the VPC and subnet first, so that you know what is our baseline. So I'm here in North Virginia region, and here US East 1, that's my region. Right. So we have two VPCs. Let's select the VPC where we are concerned. That is a project. So if I show you VPC 547, you can see the details around here. We have IPv4 subnet of this, route table, etc. All the default settings, CIDR, as you can see that. From here, we would like to go to subnets. So let's see what are the subnet we have with VPC 547. As you can see, we have, let me expand it a little bit. So we have public 1 subnet and public 2 subnet in 2 different availability zone, US East 1, 1A and 1B. That's where we are going to deploy our EC2 instances, right? So for our route table, we have internet gateway associated to our public route table. Here, as you can see, if I'm going to expand this RTB public, you can see there is an internet gateway associated to this. That means the subnet, 2 of the subnet in AZ1 and AZ2, they have internet connectivity. So we are good. We do have a good baseline, right? We have the subnet, ACL, and etc. is created. So now let's go ahead and start creating our uh, load balancers, our auto scaling groups, right? So the first thing what we want here is go to EC2, because right now there is no instances running, 0 instance. And what I want to do is first create a load balancer, create a load balancer, application load balancer, network load balancer, and gateway load balancer. As you know, there are 3 types of load balancers available. Classical load balancer is also there, but that is a previous generation. So let's create an application load balancer first. As you can see, this is internet facing, of course, SDN ELB, or maybe let's keep everything small cap. It's a IPv4 and load balancer protocol is HTTP. We are going to create it in VPC. So load balancer is a regional service. That's where you have to choose the VPC, and our VPC, that we have 2 VPC. One is default and one is the custom one we created, which has the subnet of 10.0.0/16. So let's select that. It has 2 AGs. We can select the subnet, East 1A and East 1B, right? So this load balancer will be listening to protocol HTTP on TCP port 80. You can add listeners, like you can create HTTPS and etc. But we really don't want that. So let's ignore that. The default one is good. You can also create add-on services like load balancer accelerators, and we will talk about that later. And also it's a good practice to apply tag. So for us, there is a tag called key SDN ELB. So most of the settings, default settings looks good here. We are good to go to the next. Confirm security setting. Must contain only alphanumeric, so it is not liking hyphens. Oh, hyphen is also not supported, as you can see. So we are going to just say SDN ELB, so that it's more readable. My apologies, hyphen is supported. So let's go to the next one. Improve your load balancer security. Your load balancer is not using any secure listeners, which is fine. Assign a security group. So for load balancers, we have to create a security group. I already created a security group, so I'm going to reuse that, and that is 547 load balancer security group, because we are using some IAM roles, right? So let's just attach one security group, but you can attach multiple security group, or you can create a new one. So I'm going to live with the existing security group. Configure routing, target group, existing target group, or a new target group. That all those things you can apply here, and you can also mention the health check. So this is going to check protocol HTTP. So we are not going to create any target group as of now, because the target group should come from application, uh, ASG, automatic scaling group. So when we create an automatic scaling group, it ASG will automatically register those as a target group here, right? So let's not create any target group. Health check, the default health check looks good. Advanced health check, you can also include advanced health check, healthy threshold, unhealthy threshold, etc. But the default values are good. So let's go ahead and go to the next step, which is register target. Target group cannot be empty. Okay, so we have a target group, app target group. Let's try to create a new one and see what information it want. It doesn't want anything, it just want what kind of instant it is. So we are going to use EC2 instance. So let's stick to existing target group here, which is 540 app target group, right? Rest of the things looks good. But mind it, there is no EC2 instances in that target group. It's just a placeholder. And register targets. Do you want to register target? I don't want to register target yet. You can only modify this list after you created the load balancer. The following target are registered with target group, because these two instances, they are already available in my zone and they are in shutdown state. So we will go ahead and terminate them because we are not planning to use them for this demo. All right, so you can ignore that for now. And this is our load balancer configuration. So this is a load balancer listening on port 80 as protocol HTTP. It is internet facing. It's a part of 547 VPC, and it has a subnet, public subnets, US East A and B. And then we have a security group. If you are curious what goes into security group, let's go and see that. Right, so maybe this is not the right place. We will go to the CL and see it. Okay. All right, so this looks good. Let's go ahead and create our load balancer. Successfully created SDN ELB. Discover other services that integrate with load balancer, etc. And you can also use accelerator console. All right, so our ELB is created. You can see all the details here. Our DNS name is already created. And if I just copy and paste it here on my browser, this should be answered, but right now it's not being answered because there is no server, live server sitting behind that. All right, but it is AWS responsibility to create the DNS name and make it routable. Oh, at the same time, it is still provisioning. The provisioning is not completed yet. Okay. Listeners, we have a listener. It will show up once the provisioning is completed. And as I mentioned in CloudWatch video, the load balancer, since it is a managed service, we get the default monitoring of ELB, like target response time, request, rule evaluation, and so many other details. This comes by default. All right. So let's go to EC2 dashboard and take a quick look at security group, because we have reused the security group and the security group was load balancer. So let's look at it, what it has, what kind of permission it has. As you can see, it has only one permission, which says allow TCP port 80 from any source in inbound rule. Outbound rule is pretty simple, allow all, right? So basically this security group, the load balancer, will only accept incoming connections on TCP port 80 protocol HTTP, protocol type HTTP. All right, let's go back to load balancer one more time and see if the finishing is complete. As you can see, this is active. All right, all the details are here. As you can see, you can scroll and see the details. I think it's just not showing here. Let's click on edit. Yes, as you can see, we have a listening rule, which is that mean it is listening on HTTP port 80. And what is the default action? The default action is forward to this target group. Group level stickiness is off, but you can change the behavior, you can make it sticky. But as of now, it is any incoming request on port TCP80 will be forwarded to the target group. And right now, what we have in target group, we have two EC2 instances which are essentially in shutdown state. So that's no good, right? Now we are done with our load balancer config. Time to look into auto scaling group. And here, as you can see, create auto scaling group and all the details about auto scaling group pricing. So it's a complete documentation. You can read it here. How it works: you start with a minimum size, but you mention a desired capacity and maximum size. So these are the three parameters you need to define. You always want to make sure that your application have at least minimum size available. That will provide you high availability, but optimally it should always work as a desired capacity. Whenever the load increase, it can stretch to the maximum size, which is called scale as needed. And whenever the load decreases, it should come back to the desired capacity, right? So that's the idea of auto scaling group. Here we can click create auto scaling group, and you will see there are two. This is the complete like a workflow or a form, right? Step 1 to step 7. Within here you can see there is a prerequisite, which is launch template, but we have not created any launch template yet, right? So let's go back and create a launch template first and then come back to auto scaling group. Either you can click that link or you can go to EC2 dashboard and click here launch configuration. I think the launch configuration is now going away. AWS is continuously revamping their services and etc. So as you can see, launch configuration will be not supported after 2022. So let's not do that. Go back to auto scaling and instead work with launch template. Okay, what goes into launch template? As you can see, these are the things goes into launch template. Basically, you first have to name it, then you can create a version out of that. Auto scaling guidance, yes, provide guidance to help me to set up a template where that I can use with EC2 auto scaling, and then you can add a tag. Launch template content, here you can browse an AMI, right? Or you can choose what kind of uh, operating system your application will be running. So you can browse through AMI and select that. Instance type, what you want, which kind of instance you want. Is that a T2 micro, small, medium, large? All those things you can choose here. And at the same time, you want to make sure that the application is available, the backend is available. You can log into the application, so you need to supply the key pair. Okay, network setting. Uh, Create a security group or choose existing security group, and then advanced network configuration. um, Basically, advanced network configuration is not needed, but you need to pick up the right subnet, in which subnet you want auto scaling group to create the EC2 machines. So we want in public east 1 and east 2, east 1b, that's what we will be selecting. And advanced detail, obviously just adding um, the vanilla EC2 instance is not sufficient, right? You want to make sure that when the scale or load increases and you scale out, uh, that time you want to make sure that the newly added EC2 instance has the application up and running, because vanilla EC2 instance of no use if there is no application running. For that, what you can do a couple of things. You can provide IAM instance profile, so any machine to machine communication, like for us we are using meme factory user role. We remember from IAM video. And Also, you can install your application by some kind of script. Here, you can provide user data, say Linux script, which is uh, fetching packages, running, starting some services, and etc. So all those things you can provide in this template. So what we will do to save some time, we are going to just use one of the template. As you can see, we have a template here, and I'm going to quickly show you what is in this template. As you can see, we have an AMI, and we have the key pair associated here. I want to go and say modify template, so that we can just go through everything. So these are the things what we just discussed. Here the template name, provide guidance to help me set up template, that provide guidance, let's say yes. And here you can see I'm using a AMI. Here it's selected what kind of AMI, manual selected instances. I want T2 micro because we want to save cost. It is a demo purposes only. And then you can see we have SDN AWS key. Also, we are allowing a attaching a security group. You can see there is a security group there, and subnet, etc. User details, advanced details, where we have the user role, IAM profile created, and also within user data, we have the complete script, which is actually going to fetch an application, a demo application, and start Node.js, start that service. Right. So let's go ahead and provide guidance to help me set up template that I can use with this. All right, so this is because we want to use this template with auto scaling, hence I'm going to select this. And now this is the time to create a new version, create new template version. Version 2 has been created, and these are the action logs succeeded. So now we have EC2 template. Let's go back to auto scaling group. So far we have created in a load balancer. We created a launch template which will be used with auto scaling group. Let's go to auto scaling group, create a auto scaling group because we deleted initially, and this one I'm going to say SDN-ASG. Launch template version. We just created a version 2, so I'm going to create version 2, say latest 2, right? And all the informations are here. That is part ASG step 1. Let's go to step 2, and here it is asking you in which VPC you want to use. I want to use 547 VPC. Which availability zone and subnet you want to create your instances. So that's where we are going to choose the public instance 1B, public instance 1A, right? 10.0.0.24, 10.0.20.24. Both are public instances. So every time a load increases, the new instance will be created in these AGs. So we have a launch template associated. We define our VPC and subnet. That is step 2. Let's go to step 3. So it says load balancer. You can or you may or may not use load balancers. That's why the ASG and load balancers, they are not interdependent. You can use them standalone as well. But in our case, we are going to attach to a existing load balancer because we just created that, and choose a load balancer target group. This is my load balancer. Okay. VPC lattice integration. This is a new concept. Let's keep it default. We don't want any. And EC2 health check, it is enabled. Turn on elastic load balancer health check. This is recommended. So let's create that. Health check grace period. This time period delay the first health check until your health instance first finish initializing. So think of it like you have an alarm for your EC2 instance that if CPU uses increases 80%, spin up a new instance. But what if when you are creating the new instance itself, and during the creation you know that while booting sometime the instant CPU uses can spike up, so it will add another one which is basically false positive or a paradox. That's why we want to allow a cool off period for or a grace period. So first 300 second, even if the CPU utilization is high, ignore that, do not trigger any alarm. All right. Monitoring enable group metric collection within CloudWatch. For all these tabs, since it is cloud, is pay as you go, you will be very tempted to uh, have all the benefit, but please be mindful of cost, like enabling each and additional services. This is like a la carte menu of the restaurant. Each and every recipe or dish cost you. So please make sure that you pick up things which are really essential or meaningful to you, unless you have like unlimited budget. So that's our step 3. Let's go to step 4, configure group size. And this is the desired capacity, minimum capacity, and maximum capacity we talked about. So for an application to work, you need to have some idea that what is the bare minimum I want to I can serve my application, right? So say for us, it's just one. If one instance is available, at least some of the user can log in. But the desired capacity, because I know that how my demand pattern is, I know on an average I need 2 EC2 instances to serve my users. But say I'm running some kind of promotions or sales, and during that time my load spike. So I'm assuming that the traffic will be double, and hence I'm saying let's have maximum capacity as 4. So that's the concept of group size. Scaling policy. Choose whether to use scaling policy to dynamically resize your auto scaling to meet changes in the demand. That's the key. And yes, we want that. So target tracking scaling policy, choose a desired outcome and leave it to the scaling policy to add and remove capacity. So we want the intelligence of ASG and let it add or delete EC2 instances. So there are various matrices you can select or use for as a trigger condition. We will keep it really simple. As you can see, there is an option average CPU utilization, network byte in, network byte out, application load balancer request count, all those different parameters you can use. But we will just leave it to simplest one, average CPU utilization. Whenever the utilization goes, say 75%, and instance need, obviously instance should be running 300 second. So because we want to minimize the patching or operational spike of CPU instances, we want to avoid that. Hence, we'll say give 300 second of warm up time, and disable scale in to create only scale out policy. No, we want scale in and scale out automatically. Instance scale in protection. Instance scale in protection, that means once you scale in, you don't want to delete that or terminate that. So you're kind of like putting some kind of insurance, but let's that's not needed here. So let's leave it to default. Go to next. Of course, notification is important. We want to make sure that every time my ASG triggers scale in or scale out, I want to be notified. So let's add a notification. What you can do, you can create a topic and or choose a default topic. So we have a default topic here which says 574 SNS topic ASG in use, and send it to my email address, right? Event types, you can select all the event types: when the instance is launched, when the instance is terminated, fail to launch, fail to terminate, etc. All right. So first time when you create a topic, you need to, AWS will send you the email address, a email on defined email address. So let's quickly try to create one. Here, as you can see, notification to what is the subject line looks like, what will the recipient, and AWS will send you an email which you need to validate and confirm that yes, this is a legit email address, you own it, and then from there onwards it will start sending you a notification. In our case, we have already done that. So I have already validated my email address with AWS and created a topic. These are the event type. We are good. Let's go to the uh, next step, which is tag. It's a good practice to add key value pair tag, and we are going to say SDN and value is ASG. This is the final review. In the everything from step 1 to 6, whatever we have done, it's all reflected here for your review. I'm going to go real slow so that we can review it together. Everything looking good. Let's go ahead and create an auto scaling group. So remember, the group size was 1, 2, and 4. And at this point of time, we have no EC2 instances running. Let's see, when we create a SDN ASG group, what happened? Are we going to go to the desired capacity, or we are going to hit to a minimum capacity? So it is, as you can see, updating capacity. You can double click there and you can simply go to, you can find all the details here, but at the same time, you can also see what is the activity is happening, right? Activity history, launching a new EC2 instance, launching a new EC2 instance on today's date, because a user request created from desired capacity. So we had 0 instances and desired capacity was 2. So we should be seeing 2 new EC2 instances coming up. All right, updating capacity. Let's wait for this to finish. This is completed. Let's go back to EC2 dashboard and see what happens. We have 2 EC2 instances in initializing status. So ASG has completed its workflow. Now EC2 instances are booting up, and hence the status check and every other things are going ongoing. So this is great, right? ASG dynamically understand our intent, can add instances. We will also check if it registered it to load balancer target group or no. And we will also see what happened when the CPU uses spikes up. Can we go to 4? And from there, can we come back to 2? So that's the thing we want to check. But as of now, you can see with the help of launch template, we have associated that to ASG. ASG in turn has created 2 EC2 instances in 2 different AZs. And now let's go back and see if they are part of the target group or not. All right, let's look at the target group. This is what we want to see. So we have this target group here, and let's see, as you can see, we have 2 new instances, ends in 192 and 453. They became a part of this target group, which is named as app target group. So that's what it was expected, right? When we create a EC2 instance, those EC2 instances should be, as you can see, it's part of, ends in 192 and 453. They are part of target group. So that's tell us that it is working. Okay, now let's try to access one of the EC2 instance. So it has a public IP address associated, the security group associated with this first. Okay, we have a web security group associated, which says port 80, is allowed from anywhere, and the instance state is running to access the instance directly. So this is the public IP address, and what I can do, I can open this address and it will open it in new tab. The site cannot be reached because by default it uses HTTPS, right? And we don't have HTTPS available. So what I'm going to do, I'm simply going to say HTTP, and to prove it, let me just show it here once. Okay, and now if I load it, you can see my application is loading. Ignore the application, that is really not necessary. What you need to focus on is the EC2 instance ID matches what we have created here, 192, right? And obviously the IP address. In which region it is? It is in US East 1A. So this is good. Let's do the similar exercise with second instance. And the second instance was 453. Let's go and launch this. As you can see, the IP address is different, 34, and it has similar problem, HTTPS. So let me take away the S and just use HTTP. We have our application loading configuration. You can see it is part of US East 1B, instance ID end in 453. So things are working for us, but accessing the EC2 instance directly, that kind of defeat the purpose of entire fault tolerance and auto scaling group, etc. What we actually want to do, we want to use load balancer to access our application, and behind the scene load balancer will be talking to the actual servers, right? So let's copy the DNS name here, and since my load balancer has the EC2 instances registered as a target group, let me show you the picture again. So we have 193, 192 instance here and 453 instance here, and now we are trying to access it using load balancer DNS, right? So let's go ahead, and as you can see here, so SDN ELB, this is the load balancer address. And what I'm going to do, so when you access that load balancer, see where you are, which instance you are connecting to. You are connecting to 192. If I happen to refresh it a couple of times, you can see now I'm connecting to 453. Refresh again, and so my requests are getting routed to two different AZs, and that give us the load balancing, right? Because obviously it's a load balancer. Let me put it back here. Okay, now let's go to EC2 console. So far, everything is working. We know load balancer, we have created ASG, created, and all the workflow is working really fine. Now let's go and do the final set of check. And what is that? Stress test. So in ASG, we define that the desired capacity is 2, but every time our instance CPU spikes above 75%, and it persists for 300 seconds, then create one more instance. And when it happens again, add one more instance. So, but don't keep on adding instances. There is a upper limit to that, and that is the maximum instance. So what we are going to do, we are going to again access our application using load balancer, or I have it here. And within this application, we have an inbuilt tool which can spike the CPU uses. And let me say stress application server for 10 minutes, which is more than 300 seconds. So here we have to wait for at least 5 minutes because it is trying to spike the uses for 192 in AZ1, and you will see very soon it will hit 100%, as you can see on screen. What is expected here while this is going on, right? While this is going on, AWS should AWS ASG should receive this, right, or understand this behavior, and it should trigger the automatic scaling. This is our target tracking policy. As required, average CPU utilization for 300 seconds, add and remove capacity unit. So this is our policy. We can watch things live in activity history. So when we started, we had 0 instance, and ASG created or added 2 instances because that is our desired config value. So we have 2 instances running, and now out of that, 1 instance is actually spiking, CPU spiking, and we are waiting here so that ASG can go ahead and add 1 more instance. You can also monitor that same thing at EC2 instance level. So very soon you will see 1 instance coming up. And also, whenever this thing happens, we are going to receive a notification because we have a topic created, and the topic is related to this policy, this CPU spike policy. So every time a new EC2 instance is added as a result of ASG, we are going to receive an email. If you are wondering, as you can see, this is still spiking. So we very soon we should have 1 more instance in subnet 1. You can refresh things here, but obviously it will take 5 minutes. I wish we have um, stressed a little before. These are all the things. We have auto scaling group, we have the key pair security groups. So to select your security group or auto scaling group, and then it can show you all the details. This is good time to go to CloudWatch. So this is our CloudWatch, and right now I have some alarms created. You can also create alarm, all alarm. You can create an alarm, select metric. Say for example, I want to monitor auto scaling. Then I can have a group metric here. I can create metrics. I can add query and all those things you can do. Like for EC2, CPU utilization, average CPU utilization, and all those. So you can create various alarm. I think it makes sense to have a dedicated uh, talk about CloudWatch. So let's not confuse ourselves. Go back to EC2 and stick to ASG. All right, as you can see, at this time we have a monitor alarm target tracking created, and because of that, what we are doing, we are increasing the capacity from 2 to 3, right? So alarm triggered, and now ASG started adding 1 more EC2 instances, waiting for instance warm up time, and we will allow another 300 seconds to go to to add fully functional instance. As you can see, there is still only 2 instances running, but ASG can tell you that it is already planning to add one more, that is listed here in activity. You can see the status is changing. I think for demo, adding a 300-second warm-up time was not a good idea, but it depends on your application, how fast or how quickly you want to add an application. So once we have the EC2 instance added, what we are going to do, we are going to stop stressing the CPU, and by doing that, we will have 3 instances running uh, normally, and that is against our desired value because our desired capacity is 2. So ASG group should intelligently detect that the desired capacity right now is running 3. However, by definition it should be 2, so it will take down one additional instance automatically. Now which instance you want to take away, that depends on your policy as well. You can define whether the oldest instance should be terminated or the newly added instance should be terminated. All those kind of like a control you have. All right, now after 5 minutes of long wait as an instance warm up time, as you can see, we are launching a new EC2 instance. Okay. If I go to EC2 dashboard, you will see a new instance will be start showing up real soon. If let me clear the filter and see if we have something in initialized stage. All right, so ignore the server 1 and server 2, they are stopped. One was terminated, we just terminated before we started, but as you can see 192 and 453, those were 2, and we added one more, that is 61F. EC2 instances running 3. Right, let's go to Auto Scaling Group, select that activity. So we added one new EC2 instance, 61F. All right, now what we can do, we can just stop stressing. Okay, so we are not stressing, but what we will do, we will check if the newly added instance can serve the application. And how you would like to do that, you would go to load balancer. Within load balancer, copy the DNS name and try to access your application. Okay, go to configuration. We have 192, the one which we were stressing. We have 192, 453, the two older ones. And let's see if we can also get to the newer one, which ends in 61F. So as you can see, we have all 3 applications serving the load, and we didn't have to create anything uh, manually. Everything was automated. So now we have one more uh, EC2 instance serving the application automatically spinned up in one of the subnet. Now, so we have stopped stressing. We know that we can scale in, we can also scale out. And for that, we need a full 5 minute of quiet period. That means where the CPU uses are not spiking. So what will happen in that case? In that case, our auto scaling group will sense that, and it will trigger another alarm, and that alarm is actually bringing the configuration to the desired capacity. Right now we have 3 instances running. Once we have everything stable, and if we are out of desired capacity, or we are not in line with desired capacity, ASG group will do the needful, and in this case it is going to terminate one of the instance. So here again, we have to wait full 5 minutes. Perfect. Within 5 minutes of inactivity, as you can see, we are terminating an EC2 instance 192. So looks like we are terminating the oldest instance, and that is the default. So let's look at the cause. A monitor alarm target tracking triggered, and what it is happening here, policy changing the desired capacity from 3 to 2, because our desired capacity is 2. An instance was taken out of service in response to the difference between desired and actual capacity, shrinking the capacity from 3 to 2. Right? So pretty intelligent. Let's try to refresh it again. Waiting for ELB connection training. So it's not that it just alarm is triggered and it just take out this the instance ad hoc. It makes sure that any connections going to that server is drained, and then only it is going to take down that interface, right? That's what it is telling you, waiting for elastic load balancer connection draining. Since our setup is not very busy, it should happen pretty quickly. Maybe there is some specific uh, default time for this status, but by this time, let's go and take a look at EC2 instance. We are still running 3 EC2 instances. They all are in running state. So if you are a network engineer, you can see there are various networking concept like TCP timers kind of things used here. So even before terminating a connection, when you receive the fin bit, you have various timer. You wait till the connection or the last flight byte in flight received, and then only go ahead and terminate the connection. So similar to that concept we are applying here, waiting for ELB connection draining. Yes, now you can see we have only 2 instances running. If we refresh this, you can see 192 is gone, and that was because of my auto scaling group policy. Perfect. The instance is already terminated, so we are good. What I'm going to do now, I'm going to simply go ahead and edit my group and make everything desired capacity 111 and save it. Desired capacity 111. This should trigger another set of alarm, and we should see one more instance being taken out of the service, right? But I'm not going to wait till that, because we have proved that we can dynamically scale in, we can dynamically scale out. So I hope you like this hands-on demo and all the concept about AWS as a crash course. If you found this helpful and beneficial, please share with your friends, colleagues, and spread a word. And thank you for keep on coming to SDN Tech Forum. Thanks.